13th, from the portion of mechanics and more specifically the circular dynamics part is there. It says a smooth wire of length 2 pi r is bent into a circle and kept in a vertical plane. So that's the circle of radius r. And this is, rotated about its central axis, which is clear, with an angular velocity omega. And there's a bead which is here, and at a certain value of omega, the bead is stationed here and it revolves around. Yes, the radius would be r by 2, but getting stationed here. And we need to calculate that value of omega square, for which the bead would revolve and keeping its position here. Well, it's a simple concept of free body diagram, but here let me draw the reference. This is the case. Now, if I make the free body diagram here, one is this, the weight part, and second would be the normal reaction part, right? So here, this is the mg, this is the normal reaction, and it's so clear, this being r by 2, so this angle would be 30 degree. Likewise, this angle would be 30 degree, so in radian that's pi by 6. It's all done. It's moving in circular motion in this thing. And I'll tell you one more thing. If you are practiced about the concept of conical pendulum, this is not a new thing. It's the same idea. There you keep a thread and you start revolving in this fashion. Here, instead of the thread, the bead gets entangled on the ring and revolves. The idea is very much same. You can analogize. Okay, so here what you get is that n cos pi by 6 is equal to mg, and then n sine pi by 6 would be equals to m omega square times the radius, and the radius is r by 2. All you need to do is this much. And you wanted the value of omega square, you just divide it and you would get the value of omega square. So the correct option for this is going to be option number 3. So option number 3 is the correct option for this question. Let's move to the next. 14th question I have here, and that is, you see the figure is very clear, something related to total internal reflection. And the outer medium is of refractive index mu1, and this is made up of refractive index mu2, and mu2 is greater than mu1. And therefore, there is a total internal reflection happening. But what is the question? The question says that we need to find the relationship between theta, mu1 and mu2 if a TIR is happening. So the expression is here, say. The options, if you see, the options is a relationship among theta, mu1, mu2 when a TIR is happening here. Let's see. If I call this angle as r, so quite obviously this angle would be pi by 2 minus r. It's a straightforward one. The first thing is, say, sine pi by 2 minus r, that sine of this angle of incidence has to be greater than mu1 upon mu2. That's the first condition. Sine angle of incidence greater than 1 by mu, where mu is mu denser by mu rarer. That's a condition which is required for TIR. Second, of course, it's very clear here that mu1 sine theta will be equals to mu2 sine r. The Snell's law between this and this angle. These are all two equations. So one is cos r, other is sine r. You can use the property of squaring and adding, so that sine square theta plus cos square theta, you can equate it to 1, a regular feature, not a greater deal. After all those calculations, when you see, you would get option number 4 as the correct option, the relationship among mu2, mu1 and theta. All right, let's move to the next question. Question number 15, a straightforward one from kinematics. it says that a particle is moving with speed v equals to b under root x along positive x-axis. We need to calculate the speed of the particle at time t equals to tau. One way of solving this is, you do it by integration and all those things. But I think we can also do in this way, because v is directly proportional to root x, so that's a clear indication it's a uniformly accelerated motion. So just by comparing, you can do root of 2ax is b root x, where a would be the acceleration. So clearly a equals to b square by 2. Now once you get acceleration as b square by 2, speed at any instant for a UAM would be at, and the time is tau. So just multiply this by tau, b square tau by 2. Option number 3 is the correct option for this question. Well, you can do it by the differential equation, but as I said, let's try to do it in a bit different way. Now let's move to 16th question.